And I will share my screen. Okay, I'm gonna move this around and we're gonna get going. So hang on. All right, so here we go. Just to check, you guys can see my PowerPoint and you can hear me. All right, everybody else? All right, good. So I haven't checked the inbox. I checked last night and I haven't checked this morning. I had a couple of the lab reports we're in. Did a good job of answering the questions, screenshotting or used the snipping tool to paste that into the report, and then getting the JPEG and then putting that into the report. So the reports that I did get were super clean, and I need to get the other ones turned in. So also, I want you to take a look on the D2L, take a look at your grades and see what work is missing. I know that there's a lot of people that have a lot of work that is partially done. But I'd like to get that in. So on a scale of 1 to 10, do you understand that I just asked you to go in and check D2L and find out what assignments you are missing and that you know how to do that? Scale of 1 to 10. Got 10. Oh yeah. So let's figure out and start getting this cleaned up about where we're at. Okay. Another announcement. So I am not going to be here next week. So here's how this is going to go down. I just want to be sure everybody's good with it. So next week, Monday, is the lab. Okay, so Dave is going to run the lab. Dave's an adjunct. All right, Dave knows a lot about machine controls and power circuits and all that kind of stuff. Dave Bledsoe. Has anybody had Dave Bledsoe for a class? Anybody for 110? All right, so you got Dave for, yeah, and Evan, who do you got? No, Evans, you don't have Dave. Okay, so Dave Bledsoe is going to be covering the class. Now the lab is on CAD, okay? So there's really a machine control circuit, but it's just drawn on CAD, all right? And so Dave doesn't know that much about the CAD side of it, but this is the machine control circuit that we have people draw in, the same one in like 232. You know, we've done a lot of CAD in this class. We got CAD in our classes, our PLC classes. So the CAD lab that you're doing, hopefully is going to be self-explanatory and that you can work your way through it. As a matter of fact, this is another one. This is another CAD lab that you can probably do at home and then just submit the PDF of it. So Chris, you're just getting on. Chris, have you had 232, ELTE 232 or not? Chris, you've had 232. Okay. This is the same CAD assignment that you also do in 232. So once again, you can do this at home if you want, or you can come in and use our computers to do it. But Dave is going to be covering the class because I won't be there. So when you do the CAD assignment, it wants you to insert symbols, not from the symbol library like I did, but you're going to create your own symbol library. So you see here, this is week 10. This is week 10. Here's all the symbols. This is a fuse, this is a ground, you know, so you will need to download all of these and put them into a file. And then when you're in CAD and you go insert block, navigate to that, wherever that is on your flash drive. And then you're going to insert the symbols right here off of this. Does that make sense to you guys? What I'm saying about the CAD here and how to download these symbols and then run through the CAD. The symbols you need are here. That seems like it's making sense to you? And they're all here. You're more than welcome to come in. You guys kind of work together. You guys have been doing a pretty good job with the CAD of kind of, you know, looking, you know, what's going on and everything like that. You just go like this. You just take this, you click it, and you click download. And then it's right there, right? There's the CAD drawing. And then you're just going to take this. There it is right there. And you're going to put it onto your, you know, whatever folder, you know, week 10 AutoCAD. Just drag that into on your flash drive under AutoCAD, and then download the next one and the next one and the next one, right? So that you'll have all the files. You just got to download each one individually. And so whether you go in there and you start by downloading them all, that's fine. Or if you download them as you go. And now the thing is, with a new CAD is like once you insert this, it's kind of cool. It kind of pops up almost like the way that we've been learning, so that it's available to there'll be a little box on the corner when you're doing AutoCAD that they're available to drag in and work with. Okay, so that is the lab, and once again, it's just the drawing. Control lab report, convert the AutoCAD into a PDF and send it in there. So there's no, the only report is the drawing itself. So that's what you got going this week. So once again, I'll ask again, scale of 1 to 10. That's what you're doing. Do you feel that you can either do it in class or you can do it at home? But feel free to come in class. Dave will be there if you like using the big screens better. But you understand what their assignment will be. Yeah, and you'll work your way through it. All right. I mean, here it is right here. Where's the lab? Guide sheet, worksheet, lab. It's right here. Let me just take it here and we'll just look at it real quick. It's going to come up because we found, oh, okay, I don't believe you. Let me just find it here. I'm going to pull it up for you real quick. Week 11, I want CAD lab. Week 10, CAD control lab right there. Let me just pull it up. So it just is AutoCAD. So, you know, it just talks about kind of how this works. We'll start with the power circuit. You'll need the following blocks: M5, OL3, MS, CB3. These right here, those are the ones I said you had to download. So you're just going to download them. This tells you to navigate to a folder, but you're going to make your own folder. You're going to put these blocks, you're going to put your things into the folder, because then when you do an insert block, and then you'll just start building this up kind of like this, and you'll follow the instructions to turn your thing on. Okay. Write this down on your lecture sheet. Like this motor right here, when you put it in, you know, T1, T2, M, motor, HP, all this stuff is all one thing. So you need to break it up. So the command for that, everybody, if you want to write that down, is explode. If you type explode and then click enter, it will let you pick, this, and everything will be picked, and then click enter, and it will break it all into a million pieces. And then you can put a 2 horsepower motor, 1760 RPMs, amps, everything like that. Okay, so that's how. Everybody write that down. Explode, and you guys can work together. And so you're just going to go through. Your snap will be on, and you're just going to work through and build up this circuit by inserting symbols. This lab really is not one of the harder ones. All right, and some students did it in 232. So that's what your lab is. And when you get all done, you'll have a lab, you know, with a, you know, looking like this with a power circuit and everything like that. Okay, so that is what the lab is doing. Now the next thing is, I'm gone. So right here is the pneumatics lecture. Okay, so the pneumatics lecture. And so what I won't be here, but I want to do is I'm going to put it on the WebEx or the D2L. Okay, this is going to be on the D2L. And the way that's going to work is that when you come to fluid power right here, it says the lecture for this week, blah, blah, blah. This first part here is going to have a video link for the lecture. It's an asynchronous lecture. You can watch it and fill out your worksheet, but it'll be right here, fluid power. There'll be a link for the fluid powered lecture, and then you'll watch it and fill out the lecture worksheet, okay? Because I won't be here. Does that work for everybody? On a scale of 1 to 10, does that seem like it's going to be able to work for you to watch the lecture and fill out your worksheet? It's going to be right here under week 11. When you click week 11 at the top there, okay. Does that, and if that works with you guys, that's what we'll do. And then we'll come back. And we're nearing the end here of labs. We got a few PLC stuff you're going to like, but we're getting there. Okay, so that's the schedule as we move forward here. All right. So let's go back to today's agenda. We're going to review week 9. Our lecture. We'll have a quiz open after this, and then you'll be doing your lab, your CAD lab with Dave / on your own. gather these materials. We're going to work through this like we did last time, machine controls. But let's start with our review. So there are different standards for electrical symbols. LCC uses the ANSI JIC symbols. That is the library that I gave you, that you're copying, pasting, and making diagrams using those symbols. The lab you're doing next week is the same kind of symbols, ANSI JIC symbols. So we're staying with those symbols. Although there are, excuse me, the ANSI symbols. Although there are IEC symbols, international symbols, kind of like the metric system, but that we don't use as much, all right? The company that you work for will dictate, the standards that you're going to use for your customer base, but you're going to see, both of them. Push buttons are momentary switches. So when I push it, it goes, the normally open contacts close, normally close open, and they have normally open, normally close. And I let go of the button and they return to the normal position when I'm not activating it. Okay, everybody feel good about a push button in the normal condition. The normal is the unactuated position. Okay, good. Well, whereas I'm the actuator, I'm the one that actuates it. Toggles are maintained. That's the ones that you click. Okay, and they don't have a normal position because it's wherever somebody left it, on or off. And they have a switching common. All right, and we talked about a truth table, how to go through there. Ladder logic diagrams use different symbols organized on ladders rungs in order to depict logic. So we flatten the logic out, or to flatten the circuit out to make ladder logic, and then that helps with our connections. They can contain the basic components of the wiring, voltage, conductors, switch, and load, but use rails to indicate voltage potential. There's rails up and down, L1, L2, and then rungs are where we put, all the logic. So that's what you've been building. You got rails, L1, L2, that's your voltage. Touch there, you're going to get electrocuted. Over on this side, on the left, are your inputs. Over here, here's a solenoid. One solenoid, one PB. Are your outputs. Inputs, outputs. Everybody feel good about the way that the ladder logic is organized and able to read what's going on. Trying to get continuity across from here. Voltage read rolls across this way. Yeah, ladder logic. Yep, everybody's hopefully feeling pretty good about it. And circuits contain switches in series. So we want to make an and, we can have 1 and 2. I have to push both of them in order to combine. And is something in series. Or contains where there's more than one path of electricity. So if you come to some location, let's say electricity is flowing, and you get to this node, and you can go left or right, let's say another push button here, that's an or, where you have more than one path. But up to this point, there's only one path. You only have one direction. There's no exits on this highway, but on here, there's an exit on the highway. You can go left or straight. That's an or circuit. And or circuits contain a mixture of both, some series, some parallel. All right, and basically there's really only one output per rung. All right, if we want another, like a motor, we got to make a new rung down here. If we want to do a control relay, we need a new rung down here. Whenever you have another output, you need a new rung, and then there's going to be switches over here to turn it off and on. Let me turn this off. Hang on. Yep. A relay. Now we started just talking that a relay is an electromechanical switch, and that's what we're going to really be working on some more about. What a relay is and how it works. Okay, that we just introduced it. Okay. We have a new in-class worksheet, and we're going to keep going where we left off. So that's what you have the new. I also have a quiz review that we want to do. Here's the quiz on the computer numeric control. We did these things. We said a lathe has a moving tool and a stationary bed part. So the lathe, it moves. Let me look at this. Yeah, we did. So a mill has a stationary tool and a moving bed part, but they're turning and then moving. What is not a benefit of using a CNC machine? Increased worker skills. That's not really a benefit, because sometimes increased worker skills means that you have to pay more for that employee. okay, but it does increase production and quality and everything like that. Not an advantage. Complexity requires longer setup times. Yeah, it's true. It is complex, and that's not necessarily an advantage, or disadvantage. But what a disadvantage is high initial costs, cost of programming. Like I said, you need somebody more expensive. Cost of specialized maintenance, right? That's a disadvantage. Need to keep machine producing, right? But once again, once you get this thing, set up, or programmed and dialed in, you can run a lot. Okay, in your setup times can be a lot shorter actually. Process does stamping fall under? Stamping is when you change form. Here we're talking about making a circle 4-inch diameter. I don't think that was on that exact one was on the quiz. What is the benefit of simulating CMC? To see if it makes unwanted cuts. You're going to simulate to see if it makes unwanted cuts. So you don't break the machine. What is true about incremental moves relative to the current location, right? Where absolute is the XYZ coordinate system from 0, 0, 0. What is the difference between milling and drilling? Milling takes off material in direction perpendicular to the bit. So a drill moves up and down vertically, but a mill also then moves perpendicular to it. Servo motors are used to provide feedback, like how fast am I moving, how much have I moved, what's my RPM, stuff like that. So that was the quiz on CNC. All right. So we got a pretty kind of a short little lecture today, just because we're talking about relays. That's the main goal, is to talk about relays and a little bit about the power circuit. So a relay is a switch. It could be solid state. What does solid state mean again? Do you guys remember what solid state means? We've talked about it a little bit with computers. What's solid state? A transistor is, yeah, it's a switch with no moving parts. So when that switches, there's no noise. There's no click, 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 or nothing moves. It's a fancy electrical switch. And like I said, here's a, it doesn't look like much, but this is a solid state relay. When I turn this on, it just is on. You don't hear click, like a switch closing. All right. Versus the relay that we're using right here, this actually moves. So it's definitely not solid state, because this is a switch with moving parts. The other one's a switch without moving parts. Okay. And that's what we're doing. We're basically looking at an electromechanical switch. It is a coil that's connected and drawn as an output. So you got to turn it on. You got to turn the relay on. And then when you turn it on, it has contacts that either close or open, and they're connected and drawn as inputs. So here's a relay. If you put this side over here and you make it to voltage, the coil will get electricity. And we talked, a coil of wire makes a magnetic field. So on this side, the purpose of turning it on is to make a magnetic field. And then it's going to move. It's going to move like, kind of like somebody pushing a push button. And then on the other side of the magnetic field, it is going to close the contact, because a piece of metal will move based on, how that relay is working. Okay. So if I look at my in-class worksheet, let's see what I got going here. It says examine a control relay and connect the terminals to the voltage depth. So on this, 17 and 18 are what turns it on. Okay. So I'm going to take my voltage right here, and I'm gonna bring my voltage in right here, and I'm going to hook it directly to 17, and the other side is going to go to 18. Okay, and that's a coil. So when I just flick this on, notice that this is going up and down. So this is moving up and down because the magnetic field is pulling that down. Does that seem like it makes sense at scale of 1 to 10? When I put voltage here, I get a magnetic field and it pulls this down. Everybody, does that make sense? That's the gist of what a relay is. Versus a push button right here, I can activate it, but I got to do it. There's no magnetic field, causing these contacts to open and close. This is a magnetic field doing it. Okay. What number ones are normally open and normally closed? Well, if I look at the side of the relay, This is the symbol for normally open right here, okay? And it's labeled, 1 and 2, for example, 1 and 2. And this is a symbol for normally closed. And I looked over here, it says 3 and 4 are normally closed, okay? Versus if I looked at this one, I can see that 1 and 2 are closed already. And then when I push it, it closes, and then 3 and 4 close. So this would be normally open, and this would be normally closed. It's just being activated by me. And then, but on this one, this is open, and so when I activate it, it closes. And this one's normally closed. These are all normally closed, any one of these. And so when I push it, they open. So does everybody seem to indicate that that makes sense to you, that there's contacts on a push button and there's contacts on a relay? Does that make sense? Scale of 1 to 10? Yes. Okay. And I'll show you. It says 1 and 2 are normally open. Well, I got my multimeter again, which I'll get set up. You guys can't hear it beep. All right. I'll set it up like this up here. And you guys were using a multimeter on continuity to figure out what was going on, right? Like here, I set it to the horn. That's continuity. I touch it. It's beeping when I touch. And here was the push button, remember? I put it black, and when I push the button, it's beeping. Beep, beep. So first of all, on a scale of 1 to 10, do you feel like you're pretty successful at using the continuity here to figure out which contacts are closing, when you push the buttons and stuff? Yeah, you did a good job with that, like trying to figure out, here's the switch, and you just hooked it and moved stuff around. For some reason, we had a bunch of, you couldn't find the normally closed or normally open on limit, but you eventually found it, right? Well, if I come here to, it says 1 and 2, we said were the opens. So I'm going to go right here, 1 and 2. And look at, if I push this button, beep, 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 it's acting like a push button. Or if I come over here and turn the voltage on, it's beeping, beep. So I can cause it to beep, or the magnetic field can cause it to close and beep. So 1 and 2, it says, are normally open. And then it says 3 and 4, it's beeping right now. It's driving me crazy, it's beeping. But if I turn the voltage on, it opens 1 and 3. Those be all of a sudden it's now activated and it's switched and it's open. Now it's beeping again because I turned it off. So this has normally open and normally closed contacts on it, and it's just activated by voltage instead of me pushing the button. That's really kind of what we're looking at for the relay, and that's what's showing here. There's a lot of different ways. I was drawing this for you last time, where I was trying to be a little more, what you might show from a cutaway in the book, where you have a coil of wire, and that was 17 and 18. So when I put voltage right there, I get this magnetic field through here. And what that magnetic field does is it's going to pull this switch, this piece of metal over, click, towards the magnetic field. And this was 1 and 2. And the magnetic field closes that. So that's kind of what this looks like. And then, that's kind of what it's showing here, coil, and then the magnetic field closes these contacts, right? And now it's important to understand that over here on the coil, this relay that we got turns on using 120 volts. So you're going to be hooking when you hook these up, like we've been hooking up circuits, be careful because it is 120 that turns this on. But coils have a lot of different voltages, like this little control relay right here. This one says 12 volts AC. So this is only a 12 volt relay. If I were to take, this is 12 volts. If I were to take this right here, this voltage, and hook it up to the coil here, what do you think would happen? This one's rated for 12, and these are 120. If I were to try and turn it on, what do you think is going to happen here? Any guesses? We're going to get a fire because this is 120 volts and this is only a 12 volt device. It's way too much voltage and it's going to cook it. Do you agree? Does that make sense? Yes or no? That you know, if you over voltage something, you're going to cook it. Not good. Yeah, okay. But that's what this is. Now, there's different relays. Like this one right here says this one runs at 120 volts. So yeah, that would work fine. If I hook these on here, it would actuate. It would be just fine. I got, what's this one? 120. I thought I had like a 12 volt DC one here. Here's one that says 240 volts. So if I hook 120 to it, it's not enough. It won't do anything. And some are DC. You know, if you got a relay that says that it's DC, what are these ones here? You know, you've got a DC relay. Well, then the DC relay, once again, you know, if it's a 12 or 24 volt DC, and you run 120 AC to it, it'll cook. All right. So the coil has a voltage over here. Now the switch, you know, the 1 and the 2, that can switch whatever you want. So like we were doing this push button right here, we were hooking up a circuit. So we were switching 120. So when we pushed the button, we took voltage and we passed it through to a light, and the light is rated for 120 volts and it works. But if I had this relay, and this is a 12 volt relay, and for some reason I had 12 volts, couldn't I hook this circuit up 12 volts to here, from the push button to the relay back to the source? If I had a 12 volt source, couldn't this push button turn on a 12 volt device? Does that make sense, everybody? You know that the push button doesn't care what the voltage is. It just closes a switch, and it closes AC voltage or DC voltage or 12 volts or 24, 120. It just closes. So hopefully that makes sense to you. Same with the relay. When this closes, here's 1, here's 2. Whatever voltage is connected here, it closes. And it doesn't need to be 120. This can close 24, this can close 12, or can close 240 or whatever. It's separate, all right? And that's what's critical. If you look here on the coil, and you got the coil here, and you got the switch over here. Let me my drawings, you know, better. Let me go back to my drawing. So, you know, we did, you know, 120 volts over here to close 17 and 18. Well, let's say we want to go bigger. Let's say we had a voltage source over here of 480 volts, something very large, going to a big motor. Well, then by turning on this coil that's rated for 120, closes the contact, and all of a sudden a huge motor comes on, because they don't touch each other. The only interaction between this and this is magnetic. It's just magnetic. The wires don't touch each other. Does that make sense? These are two sides of a circuit. They're isolated. They don't actually touch. One's the output, one's the input, and a magnetic field separates them. How do you feel about that? Scale of 1 to 10. Yeah, they're separate. You got the input side, the switch side, and the coil side, and they don't actually touch. This wire does not run through to there. No, it doesn't. It doesn't. The only way that these two interact are through magnetism. So you get that. That's called isolation. It kind of isolates this side of the circuit from this side of the circuit. So what is it asking here for on the worksheet? It says, we did this, we did this, we did this. Oh, in order to measure, we did this. What happened to repeat the process? Okay. And so if you were going to draw the ladder logic, okay, I'm looking. I'm looking at this worksheet. If I'm going to draw the ladder logic, 1 PB turns on a control relay. It would be, you know, L1, L2, and we would have 1 PB turns on a control relay, right? Like that. So 1 PB turns on a control relay. And so what we want to do is we want to test that. So if I wanted to test that, I would take my voltage source here. Here's my voltage, and it says power goes into a push button, So I'm going to come, let me put this over here. A little room. My voltage over here. So there's my push button. So I got power coming out of here, and it's going to the normally open of the push button. The push button goes to 17. That was my coil. Okay. And then 18 goes back to line 2. 18 goes back to line 2. So there you go. I'm going to turn my power on, and I'm going to look at my relay right here. So when I push the button, the relay comes on because it's delivering voltage to 17. I get a magnetic field. The magnetic field pulls down the plunger. That this demonstration makes sense. Scale of 1 to 10. Push button turns on a relay. Push button's making a magnetic field. Boom, and the relay's coming in. Okay, wonderful. So, and once again, you're like, well, you got to push the push button. Why not just hook it right up? Well, this is just the start to everything being automated, to where the machine turns it on and everything. Add the circuit to the AutoCAD drawing using the template. Using that template, could you guys, use that copy and paste to create this, right? Yeah, you could, right? Push button, all the symbols are over there. Push button turns on the control relay. I think you've already done that. Draw a second rung. It says the second rung is the normally open contacts from the switch turn on a red light. So now I'm using the normally open contacts, turn on a red light. Oh, my bad, excuse me. Push button. Right, is that right, everybody? I made a mistake there. That's a push button. You guys concur? Should be a push button. Okay, right. Now it says contacts turn on a red light, which is 1 and 2. Turn on a red light. So let's hook that up. So here we go. Got this. Here's my red light. So according to this, I got coming from power, I'm going into 1. So let me get a switch here. So coming from my power, I started here. There's my power. I'm just stacking it up on the power here. Notice how everybody see how I just came off the same power there. Power goes into 1, which is right there. It says 1. So there's power into 1. Coming out of 2, it goes to the red light. So 2's over here. Here's 2. Right here it says 2. Here's my red light. And then coming out of the red light, how's that? Coming out of the red light, it goes back to my neutral. So I got another wire here. I'm going to go on one. So coming out of here, it goes back to there. Okay. So I'm going to turn my power on over here. And once again, if I just manually push the relay here, I'm going to close 1 and 2. So it's acting like a push. It's acting like, I'm just closing this and the light comes on. Or I can push the button, which closes the relay, which closes the circuit to turn on the light. So if I push the button, the purpose of the button is to turn on 17 and 18 here. And once 18 is on, 1 and 2 close to turn on the light. Okay, so I got kind of a multi-circuit going here where push button turns on the control relay. This needs to be labeled control relay. Push button turns on the control relay. The control relay turns on the red light. All right. How about that? A scale of 1 to 10. How are we feeling about that? Okay. And so remember, in automation, this thing right here, the control relay 17, 18, is going to be turned on automatically by like robots and PLCs. You have a bunch of these, turning these on, closing the contact and turning on different devices. Okay. So that you can get logic and you can get everything fully automated, because all the switching occurs with a magnetic field. Once you get big, and you'll learn a lot about this at 131. I think you'll think it's great. So we did this, connect terminal 2, we did this, add a second. 1 CR, oh great, all right, here we go. I'm adding on to this. Normally closed turns on a green light. And this is still CR. CR closed, which is 3 and 4. All right, 3 and 4 turns off a green light. So I don't have a green light here, but what I'm going to do is come back to here. Instead of using 1 and 2, I'm going to switch it to 3 and 4. Okay, and it says 3 and 4 is normally closed. Okay, so now when I turn the power on, the light's on because the power is passing through. Let me get this back up here again. Hang on. The power is passing through normally closed contact right here. Power is just passing through the normally closed, so the light is just automatically on. If I push the relay myself, it goes off because it's normally closed and I'm changing the state of it. Or if I push the button brings power to 17 and 18, which switches the relay, which these two contacts here open, light goes off. Let go of the relay, this goes off. These two contacts close again, normally closed. How do you feel about the normally closed situation here with the relay? This second part here, scale of 1 to 10. Feeling good about a normally closed, turn on the green light? Okay, and you could add it to the, to the relay. All right. So let's see what else we got here. Oh, this was what I was talking about on here. And the relay says, draw a normally open push button, turns on, there's a wiring diagram. So what you would have right here is if you were going to draw it the old way, you'd have 120 volts AC going to a push button, turning on a relay. I guess I'm going to draw it like this, control relay. So if I push the 120 volts, I get the coil to come on. And this would be 17 and 18. Here's the magnetic field being generated. So on this side, I got 1 and 2. And I need a motor. So once again, I'm going to put a voltage source here of 240 VAC. And over here, I'll put a motor, a 240 volt motor. That's what we did. By pushing this button, I get a magnetic field. The magnetic field closes the contacts. These contacts complete the second circuit. And it could be a different voltage. Each circuit, voltage, voltage, switch, switch, wires, wires, load, load. Each circuit satisfies voltage, switch, conductors, load. How do we feel about it? Scale of 1 to 10 on that thing. Good. All right. You'll learn, like I said, you'll really get into this in 131. Now, a memory circuit is what we're going to hook up next. So we have a stop button right here. Now look at the way this stop button, everybody. Is this showing as normally closed NC or normally open NO? Is this showing as NC or NO? It's NC, right? NC. This start button here, is this showing as NO or NC? It's normally open, yeah, it's open, okay? And so that is the memory circuit that we're gonna make. Let me just draw it onto here where I got stop. Hang on, I'm drawing it so that I can switch cameras. Control relay. Okay, so here was the first part of it. It was going from stop to start to control relay. Okay, so what I'm gonna do, I'm gonna take this all apart real quick, and we're gonna build up the first part of this. Okay, hang on. So here we go. I need a stop, a start, going to control relay. So here's, excuse me, stop, start, control relay. Okay, so remember this is 17 to 18. So if I go with my voltage, I'm going from voltage here, I'm just off my screen, to the stop, which is normally closed, which is red. There's my red wire. I'm going from red to normally open, which is my black connector, right? There's my opens. The normally open goes to 17 right here, okay? And then the 18 goes back to the voltage source. Okay, so 18 here goes back to the voltage source. Scale of 1 to 10, do you agree the way that I hooked that up? You can read it right off the diagram there. You're able to hook this up, start, stop. This is the red, this was the red, this was the black, this was the black. Okay, so what does that do? If I push the start button, because this is already closed, the relay comes on. And so what happens if I push this, and now if I push the stop button, if I push this and then I push the stop button, it opens, right? Because at that point I close this one, but I open that one. So in order for this to work, don't push the stop button, just push the start button. But if I'm pushing it, I hit the stop button, it breaks. All right, so that's the circuit. Now, on our circuit shown here, we take the control relay contacts normally open and we run them in parallel to the start. Okay, and so what that is doing is right here, I'm running this to 1 and 2. So how does that work? Okay, so let's take a look at this. On the start, remember I told you that the best way to do this is just stack it. So I'm going to use red so that you can see the stack. So I need a contact stacked right here on the start, because this start has 1 wire, 2 wires coming off of it, and this side has 1 wire, 2 wires. So here's the first wire, here's the second wire. Same on this side. Here's the first wire, here's the second wire. So now I've got 2 wires coming off of there. And it says they go to 1 and 2. Where's 1 and 2? It's up here. So here's 2. Right there, it's 2. And here's 1. Right there. Okay? So now what happens? Turn on the power. When I hit start, it comes on. But when I let go of start, it stays on. In order to turn it off, I have to hit the stop button. So now I've got start, and it's called memory. It remembers it, and then I have the stop. Start, stop. How's that working? Well, here's my circuit. This is closed, so electricity passes through here. When I hold down the start, this comes on. Electricity comes through here, and this comes on. Which then this becomes true. These close, because these are the contacts that close. So when I let go of the start, I now have a path around. So this control relay closes, and it kind of turned itself on, because the control relay closes 1 and 2. So when I let go of this, I've got this alternate path right here. And then when I hit stop, this breaks, which means that this goes off, which means that my contacts here open. So on a scale of 1 to 10, does that memory circuit kind of make sense to you, that the relay kind of turns itself on, or keeps itself on, let's say? Called a memory circuit, okay? And that's what you'll be hooking up, all right? So how does that work? So a memory circuit, latching is a kind of a way to get memory, but if you heard latching or a holding circuit or a memory circuit or a sealing circuit or a 3-wire control, these are all different ways of talking about like a memory, a relayed memory circuit, and they're just all referring to this, where you hit start to turn this on, and then you've created an alternate, a parallel path through itself to keep it on. You have to hit stop to turn it off. All right, that is my relay. Okay, let's see what else I got in the in-class worksheet. Memory circuit, that was the normally closed stop, turns on the light. So that was what we were drawing here. Ladder logic was stop, start, CR, and then this holds CR, right? And this was stop, and this was start. Boom, that's what we had right there. Connected circuit, wire lead, start. What happens when we reverse? Wire lead. Okay, so now what we wanted to do was, and we'll need a parallel run generated. So I think that we're good on this. So remember then that this is 1 and 2. This is 17 and 18. That we can then turn stuff on. When this control relay turns on, 1 and 2 shut. We used 1 and 2 for the memory. 5 and 6 shut. 9 and 10 shut. So you can do other things like this. You can do 5 and 6. What do you want to turn on? You want to turn on solenoid? And the other ones were 9 and 10. You want to turn on a motor starter? You can do that. So by turning this on, this closes, and this closes, and this closes, and this closes. All 4 of these close. So it's like 4 switches. And we could use 1 switch for the memory, 1 switch for the solenoid, 1 switch for the motor starter, you know. So that relay can turn on a variety of different things if I hit the start button. Is this making sense here? Right here, I can turn on a bunch of, I can turn on 4 different things here with this relay because there's 4 switches on it. Although one of the things we're switching on is kind of switching itself on. So maybe we could switch on 3 different devices. All right. Now, the next part is a motor starter. And that's what we'll be doing, you'll be drawing. So a motor starter is right here. So a motor starter, up here it says 120 VA, so you can't see that. But that is the coil. So if I were to take this right here, here's 17 and 18. If I were to take 17 and 18 right here off of here and put it on onto here, well then this would come on because it's just this motor starter is just a relay. All right. And so the relay would then right here, it would like switch over. So where it says off here, it would switch to where it says on, off and on. Just like I can push this one off and on. I can activate this one off and on. But this one is the same. It's just a relay. If I put voltage here, it turns on. Okay. And when this turns on, what are the terminals called on this thing right here? Is that what it's asking? What is it? These terminals are just still called the coil, and they're labeled as 120 volts, just like this is the coil here. Okay. And then once again, if this turns on, I close a contact from here to here. So if I put my multimeter on there, let me just grab this. Let's grab a couple here. And I probably can't activate it right here, but set my meter to continuity. And, you know, if I touched these 2 right here on each end, and I was able to slide this over, you know, it's really hard to do all this at once, but if I were to pull this lever right here, it would go beep, beep, There, it's off. Beep, it's beeping. It's off. Beep. Okay. So this closes, this motor starter closes line 1, line 2, line 3. It closes 3 main contacts, and that's for like a 3-phase power. This will close as well. This will close, and then this, which is normally closed, will then open. So whenever I activate this right here, that closes, that opens. So when I let go of it, that's then back to normally closed. That's open, that's open. So right here, I don't have anything. Right here, my relay's beeping because my relay's beeping right here because it's closed. But if I come and I activate it right there, my beeping went away. Okay. So does everybody understand that this has the markings? This has open and close switches on it too. Everybody seeing it? Just like this one did. This one had open and close switches on it. This one does too. Okay. That's just a motor starter, and that's what you'll be drawing in this lab. And I can set it up for you. Okay. And I'm not gonna necessarily hook that one all the way up for you because I don't have the right stuff. So we did a memory circuit. So a control circuit uses a contactor to turn on a load in a power circuit. So I jumped ahead a little bit. So basically a contactor, let me look here. Here's a contactor. This is just like, a relay, and this is a relay. There's different size relays. This is a contactor. It closes. But this has normally open, which closes, normally open, which closes, normally open, which closes, and normally open, which closes. So when I turn this on, all 4 of these close. All right. And I got to put voltage here. If I put voltage here, all 4 of those close, 4 switches. And the reason they do that is because 3-phase electricity has 3 phases. Phase 1, phase 2, and phase 3 close. And then we use the 4th one for our memory. That's what a contactor is. It's just a it's a heavier duty control relay. You put too much current through this thing, you can see in here this little copper thing right here. That's the switch that moves back and forth. If you put a lot of electricity through there, it'll just catch on fire. It's not made to handle a lot of electricity. Inside of here, the contacts are much sturdier. All right, so that's what a contactor is. A contactor is kind of just like a big relay. All right. It handles higher amperatures, higher current, higher electricity, 3 main contacts, and a 4th auxiliary. All right. And then we looked at the motor starter. It is similar to that contactor, but even bigger, except what this does is it has a thermal overload on it. And once again, we're going to draw it, but you will learn all about that in 131. Okay. So when you hook up your power circuit, I don't know if I asked you to do that on this worksheet or not. Where it says at the bottom there, the instructor will demonstrate the 3-phase motor. I will hook that up for you next time. But what this is showing is you have 3-phase power, 1, 2, 3 legs, 3-phase, much more voltage, much more dangerous. And that turns the motor here. And that's showing that I said the contactor is 1, 2, 3 switches on it. A contactor's got 3 switches on it. 1, 2, 3, 1, 2, 3. And that's what is showing here. I got to turn it on. 1, 2, 3 turns on the motor. Okay. This is the power circuit. It's very high power, very high voltage, very dangerous. This is a transformer that brings the voltage down to lower because the control circuit's less. Okay. 3-phase power has 3 single-phase legs. That's the power circuit. It's turned off and on by a disconnect. So right here, you got like the big thing on the wall, where you pull the lever to kill the voltage on or off. That's the disconnect. Okay, 3-phase. 2 of the legs are tapped in order to bring voltage to the control. So this is it. Here, it's tapped off of here and tapped off of here to get control voltage. And the heaters monitor the motor, and that's the heater here. So you will draw this. You may not fully understand it. That's okay, but this is what you'll be drawing on your AutoCAD. Okay. And then I will hook this up next time to show you how this, we already did the start stop, but how it all works together per the lab that you are drawing here. Let's go to the bottom of this mug. I think that's what you're showing. Power circuit up here. It says stop, it says start. So when I hit start, this control relay comes on. Here's the memory. So hit start here, and this stays on. This is on, which closes this, this, and this. And then boom, a 3-phase motor comes on. If I hit stop, boom, this goes off, which opens the memory and opens the 1, 2, 3 power. So the key thing to know here is that this is the power circuit, 3-phase, and this is the control circuit. So you're going to do just a little bit of AutoCAD, once again, using that, kind of prepping you for when you might take 131. All right. And at the end there, just say, what's the power circuit? I'll demonstrate it in class. All right. So that is kind of what we're doing this time. CAD, I won't be there. And remember, I will post the video that you're going to watch for fluid power up here on week 11, because I won't be there. That's all working for everybody. So once again, just to check, scale of 1 to 10, everybody understands the plan, that Dave is going to run the lab, but yeah, it's going to be easy. It's just an AutoCAD lab. You don't got to hook, there's no hooking up, there's no nothing to do except draw the AutoCAD and get it PDF'd. Do it at home if you want. I told Dave that you might do that, or come in. That's great, either way. And then the video. Okay, so that is what I've got for you. I'm gonna stop sharing. And I'll take any question. I know it's a lot about machine control. It's just an introduction. You will get a lot of this in 131. Those that have 131 are like, yeah, I understand all this. It's cool. But if not, it's just kind of a little introduction and a little more CAD. What questions do you have? If not, you can PDF this to me, get it turned in, and then you can go take your quiz. That's where I'm at with you guys. What questions you got?